No, or discussion. Okay, so let me just check if everybody is already in front of their pieces. So just give me thumbs up for that. Right? Good, great. So it seems that most of you are already here. Anyway, so this is where we've stopped. So in here, again, I will leave now the analysis part to you guys. So everything is already there. And if ever you have a question, so just let me know. Now in here, if RL is variable, you can heavily rely with this example since everything is the same. Well, rather than doing this one, or rather than relying with analysis, you can uh just take a look on this one. So it's not cheating as long as you will be able to understand how this one were solved. Okay, but if you don't know how this one was solved, so you can maybe go with your self analysis, like how to get the is, how to get the il, how to get the rl. So everything is actually from the ohms law itself. Okay, as long as you have the fundamentals, then you'll be able to get those the same values. Okay, but anyway, here is a tip for you guys. If we have an RL as a variable, as I'm using a variable, just go with this slide, and then yeah, just base your solution with this one, since everything is the same, right? And just like what I mentioned a while ago, this won't work as a voltage regulator if the Zener diode is in here and then the series resistance now is in here. But don't get me wrong with that one, since you guys are still learning. Then there might be an additional one, like uh, there might be an additional voltage source right here, or a voltage source right here, or another diode right here, you know, just to uh, uh, make your, how do you call this one, or just help, just to improve your critical thinking, okay, or your analysis skill. All right, so anyway, so that's it for the RL, and then that's it for the VS. So I'll give you guys 10 to 30 seconds to analyze everything again. And once you're already good or done in analyzing this one, and everything is already okay, so just give me thumbs up. Right, so it's like 4 out of 10, 5 out of 10. Anyway, so that's it for the VS. So let's now proceed to the last one, which is of course RS now as our variables. In here, we have to find the minimum series resistance and then the maximum series resistance. And then the IZM is still the same. So that is our maximum current that our Zener diode allows. Anyway, so here is the formula. So a while ago, I mentioned that you can solve for the minimum value first before the maximum value. But I did also say that do not heavily rely on that one, especially if you're talking about RS, since in here we can actually find the RS max first before the RS min. Okay, so here is the formula for the RS max. We have RL times VS minus VZ divided by VZ, and then everything is already given. So just put the given values, and then it will give us a result of 10K ohms. Then after that, we can now start. finding the RS mean. So here is another tips to you guys. If you're looking for the minimum value, okay, especially on the second part, this one right here, you have to find the maximum value first, okay, or you have to find the maximum value on this part. So before we are looking for the VS max, okay, oops, my bad, but this one is also IS max. This one is RL max, but this one is IL min. Okay, anyway, so just erase that one. So there is no pattern in in that maximum value, because I've thought that if we have a maximum, or an unknown maximum value right here, we can find the minimum value of your IL. But in here, it's the same, maximum and then maximum, and minimum and then maximum. So some of them are contradicting. So that is not actually a good pattern for you guys to follow. So yeah, again, just stick with this example. If RS is unknown, then just go back with this slide. Okay. All right. So here is the formula. I mean the step-by-step solution for the RS mean. So IL is equal to VC divided by RL. So everything is already given. So 4 divided by 5K is equal to 0.0008 ampere. And then for the IS max, we have IZM plus IL. So IZM is already given, which is 45 milliamps. And then IL was already solved from this formula. So we have 45 milliamps plus 0.0008 amp is now equal to 0.0458 amp. And then for IS max, so this one came from just our general formula. Okay. So Vs minus Vc divided by Rs mean. So Vs is 12, Vz is 4, and then Rs mean is equal to, okay, so this is the unknown. So Is max is already solved, which is 0.0458. So all we need to do is transpose everything, okay, that is not needed or that is not unknown on the other side, and then leave the unknown on the other side also. So in here we have 12 minus 4 divided by 0.0458 is equal to 174.67 ohms. So we have a minimum value of 174, and then it can, it can have a different values as long as it's within the range of our minimum and maximum value. So again, I'll give you guys 20 seconds maybe to recheck everything, and then just let me know if everything is already good. Okay, very good, Mr. Segun. What about the others? If already have a question, so just let me know, okay? All right, very good then. Okay, so here is my no. If you want more examples, so you can check this link right here, and here is the reference of this PowerPoint. Okay, so most of them came from electronics tutorials, and then some of the examples maybe came from this YouTube link. Okay, so that's it for the module 6. So again, let me ask everyone if you have a question from the start up to the end, so just let me know. because we are now going to proceed to the last module, to the module 7. Right, and so if there is no question, then let's just go back here real quick. All right, so I want you guys to check this 5 links right here. So 5 links for the Zener diode, and then we have 2 links for the LED or the chapter 7. Okay, so yeah, with that you'll be able to understand more about the Zener diode as a voltage regulator. So on the first parts, first few parts, so I think it's quite easy to understand. Example 1 up to number 3, and then the first example also, example number 1 up to 1 is also quite easy since everything is already given. But in here, if RL is unknown, VS is unknown, RS is unknown, so there is no solid pattern for that one that you guys can, or you guys will follow. So you really need to memorize maybe everything from from the start up to the end of this solution, okay, or this formula. It's the same with this VS or with this RL. So all of them are different. Okay, so that makes this one quite tricky. Anyway, so let us now proceed to the last module, which is the light emitting diode. So in here, this one is super straightforward, super easy to understand, and then you know maybe you guys already have an idea how does an LED work. Well, anyway, so let's start by defining what is an LED or a light emitting diode. Okay, so as you guys can see, this is also a diode. It's just that in a form that it emits a light. Okay, that is why it's called a light emitting diode. And as we all know, a diode is a polarized component. So of course, it has a cathode negative connection and then a positive connection. Okay, so we call that one PN junction. That is a positive negative junction. So it will pass current in its forward direction. So yeah, it's the same. So with our normal diode, so forward bias connection, so it permits current. Reverse bias connection, it doesn't permit current. Okay, and then during the forward bias, and yeah, that is the only time that it will convert that electrical energy into a light energy. Okay, so the shorter one right here is our cathode connection, or the one that has a notch or a flat spot, and then the anode, that is a longer one, that is our positive connection. Okay, so cathode for negative and then anode for positive. Okay, and then in here we have the call this one like the advanced type of the LED, because basically an LED is just one wherein if it's green, it's just green. If it's red, if it's just red. If it's blue, it's just blue. But in here, we can have the RGB LED, which is which has 4 pins. We have blue color, green color, red, and then anode plus. Okay, so in here we can have more colors, like maybe combining green plus red is another color, blue plus green is another color, and then blue plus red is another color. Okay, so light emitting diodes are made from exotic semiconductor compounds such as gallium arsenide, gallium phosphide, gallium arsenide phosphide, silicon carbide, or gallium indium nitride, all mixed together at different ratios to produce a distinct wavelength of color. Okay, so in here we have the types of material that we've used, and then the different wavelengths with those different materials, and then the color that they produce, and then the voltage that it requires, and then at this specific current only. Okay, so as you guys can see, if we have gallium arsenide only, okay, this semiconductor material only, and then it was doped into this wavelength, which is 850 to 940. So this one can produce an infrared color, which requires 1.2 volts for you to produce this color. And gallium arsenide phosphide, and ranging this, ranging with this wavelength 630 to 660, will produce a color of red and requires 1.8 volts, and so on and so forth. So the lowest one that requires a voltage is this one, gallium arsenide, which is infrared, and then the highest one that requires a 4-volt voltage is this gallium indium nitride. Yes, yeah, gallium indium nitride. Okay, and this one also explains why I don't know, but this one is not like comparable nowadays, since okay, let's start by comparing the yellow and then the white white LED. So during the all these 20 years ago, in our barangay, or in our place where I lived before, so there's a lot of houses wherein they have this yellow light. Okay, so you guys familiar with that one, the yellow light? So I'm pretty sure that yeah, I'm older than you guys by maybe 5 years, but I'm pretty sure that when you were young, uh, you have already seen a yellow light, especially the kubo, yung mga kubo-kubo na bahay. Am I right? Can you guys relate with that one?
Yes, sir.
Okay, so I've just noticed this one, since Dave mentioned that okay, since like 10 years ago, 15 years ago, we already have incandescent light, like the white one. Okay, uh the 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 old people before will still choose to buy this one, since they've said that yeah, this one will save more energy, this one is much more call this one, parang mas matipid. Okay, or yeah, it won't cost you much to the electricity bill. Okay, but nowadays they were saying that this white LED now is like call this one, parang hindi na, it's much more costlier than this yellow light. Okay, before. So that is why this one is not quite accurate anymore. But if it's maybe to compared to a small and individual light, okay, yellow requires a smaller voltage than a white LED. Okay, so maybe they have this technology now wherein this one is now better than this yellow light. Anyway, so the actual color of a light emitting diode is determined by the wavelength of the light emitted. Okay, so this is the one controlling, what light it will produce. Okay, so different wavelengths, different colors. So which in turn is determined by the actual semiconductor compound used in forming the PN junction during the manufacture. So therefore, the color of the light emitted by an LED is not determined by the coloring of the LED's plastic body. So maybe some of you, well, even me before, thinks that it's only because of the covering, it's only because of the plastic body, but it's actually not. Okay, that one itself, that component itself, is the one that is producing that certain color. Okay, that specific wavelength. Although these are slightly colored to both enhance the light output and to indicate its color when it's not being illuminated by an electrical supply. Okay, so yeah, it is true that it can produce its own color, not based on its plastic body. But what if, what if it's not turned on? Okay, so we'll be having a hard time, to identify, is this red, is this blue, is this yellow? So that is why it has, its colored body to enhance, and at the same time, as an indicator that this one is a red, this one is yellow, this one is white, and so on and so forth. Okay. So again, here are the things that you guys can mix. So these are just the basic, from gallium indium nitride up to this point. But we have two additional one or three, I guess. The silicon carbide and this. I think these are the three since silicon carbide is already here, I guess. Yeah. So the additional one is this one, I think.
Zinc
This aluminum
selenide, zinc
gallium.
selenide, aluminium
Zinc
gallium
selenide,
nitride.
yeah, and then aluminum gallium nitride. So those are the three additional one for this one. So those three can create this color ultraviolet. Blue is already here. Blue is already here, and the other one can. Is this other one? Aluminum, gallium, phosphor. Anyway, so yeah, those are the colors that they can produce. All right. And most common LEDs require a forward operating voltage of between 1.2 volts to 3.6 volts. Okay, so even though in here it says that it requires 4 volts, yeah, the maximum voltage or the maybe stable voltage that this one requires is 4 volts, but 3.6 volts is already enough. Okay, so it's better to have a lesser voltage than a call this one like sobra, or the what is the English of more than that. Cannot find the precise term for that or precise word. Anyway, so yeah, the normal voltage that we have in here is 1.2 to 3.6, and then the current is 10 to 30 milliamps. Okay, though the normal one is 12 to 20. So this is the one that will always being used when it comes to LEDs. Okay, so here are the normal configurations, positive to negative. Okay, so it should be from positive node first to negative, and then the shorter one is the negative, and then the longer one is the positive. And then here are the different wavelengths, and then the different colors that they produce. Okay, and we have now here the LED series circuit. So here is the fixed formula in solving or in finding the RS, the VS, the forward voltage, okay, and then the forward current. Okay, so let's have an example for this one. So we have this given circuit. So an amber colored LED with a forward voltage drop of 2 volts is to be connected to a 5 volts stabilized DC power supply. So using the circuit above, calculate the value of the series resistor required to limit the forward current less than 10 milliamp. And number 2, also calculate the current flowing through the diode if 100 ohm series resistor is used instead of the calculated first. Okay, so using this formula, here is the solution. So we have this RS equal to VS minus VF divided by IF. So let's just go back in here. So calculate the value of the series resistor. Okay, wherein required to limit the forward current to less than 10 milliamps. So in here, all we need to do is put the 10 milliamps right here, and then the DC supply, and then the forward voltage of the LED, which is 2 volts, and then it requires us 300 ohms for us to maintain, or at least not more than this 10 milliamps. So with that, we can have a consistent 10 milliamps that will flow on this LED. Okay. And if we are going to change this 300 ohms, okay, into 100 ohms, so from 10 milliamps will now give us a result of 30 milliamps. Okay, so with the use of this formula, just transpose everything that is unknown, and then the known value on the right side, then you will get this formula. So Vs minus Vf is equal to divided by Rs is equal to 5 minus 2 divided by 100 is equal to 30 milliamps. So in here, 10 milliamps is still safe. 30 milliamps is still safe. Okay, since it says here that 10 to 30 milliamp is its approximation or the good value, approximated good value. So maybe less than that or more than that is not that good anymore. So it will easily burn your LED. So are we clear so far? All right, then. So let us now proceed to the series LEDs. Okay, so we can connect LEDs together in series to increase the number required or to increase the light level when used in display. So as with series resistors, LEDs connected in series all have the same forward current. So forward current flowing through them as just one. So as all LEDs connected in series pass the same current, it is generally best if they are all of the same color or type. Well, of course, if you guys would like to amplify the color, then those three series color should be the same, same color. And one more thing, so the reason why they should be the same is, for us to have an easier time in calculating what is the uh, good current that will flow in here, or what is the good voltage that will pass through this LED right here. Okay. Anyway, so you can have a mixed colors if you want, though it's just harder to compute the required current or the required voltage. But yeah, let's just say that LED, individual LEDs, requires 1.2 volts each. So just multiply that 1 by 3. Then we have a 3.6 volts requirements on this LEDs. And then for the series resistance, so this one is quite confusing. But yeah, we can just simply combine these two solutions. So this is the numerator part, okay, which is 1.4 volts. Okay, and then this is the denominator part, wherein we are looking for the RS. And just solve that one will give us a result of 140 ohms. So in here, if we wanted to maintain this one into at 10 milliamp current, so it requires us 140 ohm of series resistance. So we can also change this one into 20 maybe or 30. So of course you will have a different competition, and then this is that is now the new value that it requires if you want to maintain that kind of current. Okay, so are we clear so far regarding with this one? Okay, very good. All right, so that's actually it for this LED. So it's not that difficult since no, it's just LED. Okay, so you only need two components for that one. So rather than the LED itself, you need to have an series resistance and then the voltage source itself. And then here are the references. So this one came from electronics tutorials also, and then maybe some of it definition probably came from this Wikipedia. So maybe you guys are wondering why I am not sure, because this one or I made this one 2 years ago. Okay, when we still had the face-to-face learning method. So yeah, just check them out, and then yeah, those are my references. And then here are some helpful videos in understanding the fundamentals and how an LED works. So this one is a perfect video that I found that explains the basics uh, and like the complete ano ba to? It's like the complete demo on how does an LED really works. So that is why yeah, this one is in Hindi version, but I did include this one since his video is easy to understand, even though his is being in Hindi and I cannot understand anything, but through his drawings, through his the given values maybe. So that is why I did include this one, even though this one is not in English version. But if you guys would like to you know have an English version, then you can just check this one out. Okay. And then if you want to know how does an LED break, so you can also check this YouTube link. So yeah, that's pretty much it for the module 7. So any question or clarification so far?
No, sir.
Okay. So today is already our last meeting. So next meeting will be Thursday, right? But that will be your free time in order to finish all of your activities. And again, to those who are interested, okay, this last announcement. To those who are interested to join the tryout tomorrow. So supposedly there will be a 5v5 a match for us to see the skills of everybody. However, there were only 6 you know uh well yeah, who's willing maybe or who wanted to join the trial tomorrow. So I don't really know, so I hope there would be more player that I will join this tryout who will represent the University of Cordilleras. So anyone here who would like to try, so who knows, maybe if UC became a champion, then after regional we will have a national event for that one. The champions of regional will represent, and then maybe will fight the other regions, then might have a bigger reward. Okay. And then that might be your way to become a pro gamer, professional gamer, or no, baka maging job nyo yun or baka maging career nyo. So who wants to join? Mr. Santa Cruz? Mr. Awas? Or maybe Mr. Segun?
Kailangan ba ng sir?
Nang?
I can't play it, sir.
What?
I've never played Mobile Legends before.
Okay. So, all right. Anyway, maybe if we have different games, what do you play, Mr. Segun?
I really don't play games.
What? You don't play games?
I don't play games that much.
Really? Wow,
Yes.
that's impressive. You can do a lot of things, rather than wasting your time playing. So that's one of my problem actually. So instead of me learning, instead of me checking your activities, I do play games. Anyway, so do you have a question, Mr. Awas? Kailangan ng so rank,
Kailangan ba may kasama, sir?
no. All of them are actually individual players, but I do recommend you guys to have your own teammates, as long as he or she is an ICPAP student. Dapat computer engineering siya, not just a UC student. But yeah, we'll just form your team once we finalize everything, since konti nga kasi. So kahit wala kang kasama. So what, are you in?
Sige, sir, try it.
What about the others? Miss Leah Gabaldon, Mr. John Francis, Mr. Ryan Roger, Mr. Kenji, Miss Maxine, Miss Abigail. Wala na? Sayang naman. This is just for fun. So tomorrow's tryout, it's free, of course, since it's just a tryout. So the only time that you're going to pay the registration fee is, once you are now really part of the UC representative. All right. So anyway, so if just in case that you'll change your mind later on or maybe tomorrow, so just let me know. So just message me if you want to join the tryout, so we can form at least a 5v5 match. So it will be maybe the other members that will choose who is the best one for the mid laner, for the top lane, for the bottom lane, and so on and so forth. So hindi naman porket natalo yung team nyo, hindi ka nakasama sa top 5 or sa 5 members na maglalaro. So depende pa rin yun sa performance. Alright, so anyway, so just message me if your mind will change. So yeah, that's it. We now only have 2 minutes left. So if you guys have clarifications, so just let me know. And if none, so just give me thumbs up and you guys me know. And thank you guys for coming.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Are you gone?